How we doing? Looking today at second derivatives. This is on page 76 in the old textbook, and we're going to have a look at questions 1, 8, and 12. Um, so a second derivative is just where you differentiate twice. So if I differentiate this function once, I'm going to get 3x squared plus 4x. And if I differentiate it a second time, I'm going to get 6x plus 4. So why would we do this? Well, this is the rate of change of a rate. So here's an example. If you're working in the Coca-Cola factory and you've got some big tank that's emptying out down the bottom, at some stage it might be emptying at a rate of 100 litres per second. Okay, so there's the rate at which water or Coca-Cola, say, leaves the tank. Now, as the water level drops, that rate's going to slow down. So at some later point, it might have dropped to 50 litres per second. Okay, and if you want to work out when's that tank going to empty, and I can start my next batch of Coca-Cola, you will be interested in how fast is that rate changing, because that will tell you how fast the tank empties. So what you're asking about there is the rate of change of a rate of change. So that's a second derivative that you're finding there. So that's why you would want to do something like this. As to how, well, you've just seen there. I'll look here for question 8. It's a little bit different because it's not a straightforward one. This is a chain rule problem for dy dx. So the chain rule says 3 times our original function squared multiplied by, so our original function there, multiplied by the derivative of our original function is 3. So dy dx is 9 times 3x minus 2 squared. And the second derivative is going to be, same again, differentiate this, you get 18 times 3x minus 2 to the power of 1, which is 3x minus 2, multiplied by the derivative here is 3. So we're going to get ourselves 54 times 3x minus 2. This other notation you'll see for that sometimes, if f of x is notation for y, f prime of x is notation for the first derivative, f double prime x is notation for the second derivative. So you'll see that as well. In question 12, they ask you about that. They say if this is the function f of x, what is the second derivative when x is 4? So let's start off by saying, well, what is that function? That is 2x to the minus 1 plus 4x to the half. So the second derivative of that function, I shouldn't have drawn that there, f double prime of x is going to be, start with f prime of x. F prime of x is going to be minus 2x to the minus 2 plus 4 times a half of x to the minus a half. Okay, so that is going to be minus 2x to the minus 2 plus 2x to the minus a half. That's the first derivative. The second derivative is when you differentiate this function. And that's going to be minus 2 by minus 2 is plus 4x to the minus 3, reduce that by 1, plus, multiplied by minus a half, you're going to get minus 1 x to the, reduced by 1, minus 3 over 2. Now, if you wanted to rewrite that, that would be 4 over x cubed minus, because that's a negative index, that's 1 over x cubed, and the half means the square root of x cubed. So they ask you to evaluate that when x is 4. That's 4 over 4 cubed minus 1 over 4, the square root of 4 cubed. And that is going to be 1 over 16. Take away, square root of 4 is 2, cubed is 8. 1 over 8, and that's 1 over 16. Take away 2 over 16. The answer is minus 1 over 16. Okay, that's the second derivative, which might be, again, negative, means the rate is decreasing. So the amount of Coca-Cola that's spilling out every second is getting less and less as you pass. The rate at which the rate is changing. So it's a rate of a rate is what we mean by a second derivative. Right, so you'll see more of that when it comes to the problem solving questions in the next chapter. But for now, just making sure we know how to do this. Can you do questions 2 and 3, please? And in class tomorrow, can we do questions 4, 5, 6, 7, 8, 9, 10, 11, 13, and 14? Okay, thank you.